Hello students, welcome to the lecture series of M.Sc. Part 1. The subject is Mathematical Methods in Physics. This is a lecture number 5. In the last lecture, we discussed about the analytical function and some problems. So today we are going to discuss harmonic functions. So before that, I would like to introduce one small definition for the entire functions. Okay, so this entire function, what is entire function? So a functions which is analytic everywhere in a planes, this is a finite planes, is called the entire functions. Suppose we consider the one planes in that number functions, it is analytical everywhere. Suppose this is one plane and this is one region, region or the domains. So in this function is analytical in at everywhere, so we can call this function is the entire functions. Okay, so if we write in the mathematical terms, so f of z is equal to summation over 0 to infinite a k into z power k, where z is a z mod is less than infinite. Okay, this is the conditions, means it is not analytical at the infinite points. Okay, so these functions we can call this is entire functions. Here like this, numbers of function is present f of z. Okay, so this functions is analytical over the entire planes, and that's why this function is called the entire functions. Okay, so this is a small definition about the entire functions. Okay, so next main concept, that is harmonic functions, that we are going to discuss today. In the last lecture we discussed CR equations in the polar form also. So we know the condition for the Cauchy-Riemann equations or the CR equations. Okay, so just we will use this CR equation in this concept. Okay, so harmonic function. So we know the CR equation, so that is definition for this harmonic functions of functions which satisfy Laplace equation in region or the in domain is called harmonic functions. This is the functions. It's called the harmonic functions. So this is a definition for the harmonic functions. The functions which satisfy the Laplace equation in a domain is called the harmonic function. So we know the Laplace equation, that is if we write the del square into f is equal to 0. This is a Laplace equation. So those functions, that is f of z, if this f of z is satisfy this Laplace equation, so we can call this function is a harmonic function. So we can write this del square as a del dot del, like this. Okay, and we know the del value for the, if we consider the function is a two variables, this f is a two variable or the three variables. So here we are considering that this function is a two variable, that is u and v, like that. Okay, so or the x and y. Okay, so this del is a if two variables, so we can write for the del is equal to I into dou by dou x plus j into dou by dou y. Okay, only for the del is equal to what, these things. So dot second one, that is same, it is dou by dou x plus j dou by dou y. So if here is a dot, so if we take the dot product, so I dot I it is equal to 1 and j dot j it is equal to 1. Okay, and other product between the I dot j it is equal to 0 and j dot I that is equal to also 0. So just I'm rewrite, that is del square dou x square plus del dou square by dou x square plus dou square by dou y square. Okay, this is value for the expression for the del square. Okay, so if you multiply with the functions, so this we can rewrite like this: del square f is equal to dou square f by dou x plus dou x square plus dou square f by dou y square. Okay, this is for the if this function is a two variable. So here I am considering the x and y is a variable. So if it is three variables, so here plus dou square f by dou z square like this. Okay, if function is a three variables. Okay, so this is the expression for the Laplacian equation, and if this conditions here is equal to 0, if this condition is satisfied by the functions, so we can call this function is a harmonic functions. Now let's check this for the functions. If we consider if I consider this functions f is equal to what, f of z is equal to u of x and y plus iota into v x plus y. Now this f is what, function of z, and this f having the variable that is u and v, this and this u is a function of the x and y, and this v also function of the x and y, like. Okay, so now if another concept is what, if conjugate of conjugate harmonic functions. Okay, so I will tell you what is conjugate harmonic functions. If this means this functions f of z that is analytical, when it is analytical, when it is satisfy the CR equations. Okay, and this functions is harmonic when it is satisfy the Laplacian equations. Okay, so if this u is satisfied this Laplacian equation, then we call this u is a harmonic functions, and same for the v also. If this v is satisfied the this Laplacian equations, then we can call this v is a harmonic functions. Okay, so if this u is satisfy this Laplacian equations, then its conjugate harmonic function is what for the u. If u is a harmonic, then its conjugate harmonic function is v when it is a harmonic. Okay, so if these functions u is a harmonic, then this function is a analytical. Okay, so I will tell you how it is. F of z is analytical, that we know the CR equations if is satisfied, then f of z is analytical, and this u is this Laplace equation is satisfied, then u is a harmonic, and the v is a conjugate of this harmonic functions. Okay, if these two are harmonic, then this f of z is a analytical. Okay, like this. So let's prove this. If we consider by the CR equations, we can prove this f of z is analytical. If we consider by the CR equation, okay, consider the u, x and y, or f of z that is analytic. Okay. these functions I am considered a analytic. So if it is analytic means what, this CR equations conditions is satisfied by these functions. Okay, so we know the from CR equations we can write it is ux is equal to vy, and this thing or this f of z is equal to u and plus iota into v. So ux is equal to what, first derivative of u with respect to the x, and their first derivative of v with respect to y. Okay, so we can write also dou u by dou x is equal to, or dou u by dou x is equal to dou v by dou y. Okay, these things, or it is similar thing, ux is equal to vy. Okay, these things are the same. Okay, so this is CR condition, or the CR equations, Cauchy-Riemann equation. So if I take the double derivatives of this this is equation number 1, and if I again differentiate with respect to the x, so what we get, dou u square by dou x square is equal to dou square v by dou y into dou x. Okay. From this similar thing it is, if we just take the second derivative with respect to the x, so this is dou square u by the dou x square is equal to dou square v by the dou y into dou x. Okay, so this is second equations if I give the name, and the second condition is for the CR equations is Vx is equal to minus uy. Okay, so this Vx is equal to what, dou v by dou x is equal to minus dou u by dou y. Okay, so if I differentiate with respect to the y these things, so this is equation number 1, sorry, just differentiate this equation number 3 with respect to y. Okay, so it gives the second derivative dou square v by dou x into dou y is equal to minus dou square u by dou square y. Okay, this is equation number 4. Now if we add this equation number 2 and the equation number 4, so we can rewrite so like this. You can observe the dou square u by dou x square minus dou square u by dou y square. So these things I rewrite as minus this in this side, or if you multiply, so like this. Okay, so it's the same things. So if I add this to equation number 4 and 2, so that is like this, dou square u by dou x square plus dou square u by dou square y is equal to these things now. Okay, left hand side, so that is dou square v by dou y, and here is a minus, so it is dou square v dou x into dou y. Okay, so this if you compare these two terms, dou square v by dou y into dou x minus dou square v by dou x into dou y. Okay, so these are the same term, so it is equal to 0. So these equations, that is dou square by dou x square plus dou square by dou y square, this is a del square. Okay, and the u is what, functions. So this u, if it is functions, and if it is satisfy this Laplace condition, that is, if from this step, if I write dou square u by dou x square plus dou square u by dou square y is equal to 0. Okay, so this is Laplace equation. So we can write like this also: del square u is equal to 0. Okay, so this is a condition for the Laplacian equation. So u is a function, so this u is satisfy this Laplacian condition, so we can call this u is a harmonic functions. Okay, now next task is what, similarly we can find for the v, because we know that the functions f of z, if this f of z is analytical, so here is u and v must be harmonic. Okay, so that is u plus iota into v. Okay, if this u is a harmonic, then conjugate of its is what, v. Okay, that is also harmonic. Conjugate harmonic function is what, v, for the u, if u is a harmonic functions. Okay, so this is important things. In the question they ask like this, they give this u functions, okay, and they ask to find this conjugate of conjugate harmonic functions, that is v of the u, or they given v like, and they ask to find a conjugate of conjugate harmonic function of v. Okay, and also they say they find this it is analytical or not. If these two functions is harmonic, then we can say this f of z is analytical. Okay, so similarly we can find for the v also, del square v is equal to 0. Okay, same things if we differentiate with respect to the x and y for condition of the CR equations, first and second, and then take the second derivative and just add, then you get this del square v is equal to 0. Okay, so for this del square v, you can write dou square v by dou x square plus dou square v by dou y square is equal to 0. Okay, this is same thing, del square v is equal to 0, or this thing is the same. Okay, so this is about the harmonic function. So we can call this, if this u and v are harmonic function, so we can call this f of z is analytical. Okay, so let's discuss one example so you can understand better. Example, so that the function u, the function of x and y, is equal to this u is a functions 2x plus y cube minus minus 3x square y. This is a given functions, so that the functions ux is a harmonic, is a function is a harmonic function, and find its conjugate harmonic functions. And corresponding f of z is analytic. Okay, so what they are asking, so that the functions they give us u is equal to, u is a function of the x and y, and it is equal to 2x plus y cube minus 3x square y. Okay, is a harmonic function, and find its conjugate harmonic functions, means they given the u and they are asked to find the v also, and first task is what, this u is a harmonic or not, that we want to check first, and then second task is what, we want to find this v, that is a conjugate of this harmonic conjugate of this u. Okay, and third task is what, f of z, we want to find this f of z. If we find this u and v, so we can write this f of z. Okay, so let's write. So given that is u is equal to 2x plus y cube minus 3x square y. So if by the CR equations, or we know the, first I am write to this u of x, that is equal to what, dou xy, or sorry, dou u by dou x. Okay, so I am directly write here u x is equal to, if the differentiate this thing with respect to the x, so it is 2 plus, here is just minus 6x into y. Okay, and if again we differentiate the second time, that is u x into x, that is a double derivative of this u. Okay, so with respect to the x, so if we differentiate, so here is what, minus 6y. Okay, this is about the u x into x. Now same things, that is u, if we differentiate with respect to the y, so that is u y is equal to, if we differentiate, so here what we get, 3y square minus 3x square. And for the double derivative with respect to the y, so that is u y y into y is equal to this is 6y. Okay, so what is condition for the harmonic? So we know that if it is satisfy the Laplacian operator, so it is like del square u is equal to 0. Okay, so del square is, that is a double expression is like this, dou square u by dou x square plus dou square u by dou y square is equal to 0. So double derivative, that is with respect u with respect to x is equal to minus 6, or I am writing this u x plus u double y is equal to 0. Okay, if we write u x is equal to what, minus 6, and u y is equal to what, 6, so it is minus 6 plus 6y is equal to 0. Okay, so these functions that what are given, it satisfy this Laplacian condition, that is del square u is equal to 0. Okay, so we can call this u is what, u is harmonic functions. Okay, this is the first task. Now second, they are asking find its conjugate harmonic functions. Is we want to find the v, that is a conjugate harmonic function. So just okay. Okay, so from the CR equations, we know the first condition for the CR equation is what, ux is equal to vy. Okay, so this ux we already calculated, that is ux is equal to what, first derivative of this functions u, that is 2 minus 6x into y. Okay, this is a ux, so this is equal to what, vy. And the vy is equal to what, vy is equal to dou v by, sorry, dou v by dou y. Okay, so here we want v. Okay, so if it apply the integration here, so this derivative will be cancelled. Okay, so yes, it is 6x into y So if I apply the integrations, so like this, integrations dou v by dou y is equal to integration here is it, integration with respect to the x. Okay, so dou v by dou y into dx, here is also dx minus, this is just 6 minus 6 x into y, or dx. Here this integration with respect to the y. Okay, so here's the mistake. Okay, so if we integrate with respect to the y, so here dou v by dou y is equal to what, v, and here integrations 2 is a constant, so it is 2y minus 6x y square by 2 plus 5 is a function of y. Okay, sorry, function of x, it is not y. So this we can rewrite 2y minus 3x y square plus 5x. This 5x, that is a arbitrary constant, which is a function of the x. Now this 5x, if we calculate, if we consider or if we take the derivative of this v, that is with respect to the x. Okay, so v of x is equal to what, if we take the derivative of this v, so it is minus 3y square plus 5 dash x. Okay, 5 prime x. So this is a 5x, and this here is a 5 prime x, that is a derivative of 5 with respect to the x. Okay, and minus y square. Okay, this thing. So if we compare second condition, that is vx is equal to minus uy. This is a condition for the CR equations, second condition for the CR equation. So if we compare, this is a vx and it is equal to minus uy. So we already calculate uy from this given example. So uy, if that is a derivative with respect to the y, so it is 3y square minus 3y. Okay, these things uy. So vx is equal to what, minus 3y square plus 5 dash x. So if I write or compare these two equations, we can calculate this 5 prime x, or we can write this 5 prime. Okay, so that is minus 3y square plus 5 prime x is equal to, here is a minus sign, so minus 3y square plus 3y. Okay, so 5 prime is equal to what, 3y. Okay, but here we want a 5x. If we take the again integration of this 5 prime, so we can write 5x is equal to 3xy. Okay, this is with respect to the x. Apply the integration with respect to it. Okay, I am directly write here the result, 5x is equal to 3xy. Okay. And okay, now this v is what, or here integration constant, that is plus c. Okay, if we take the integration constant, so v is equal to what, 2y minus 3xy square plus 5, and 5 is what, 3xy plus c. Okay, so we can write v, that is conjugate harmonic function of the u, so that is equal to 2y minus 3xy square plus this 5x from the last step, that is 3xy plus c. Okay, so c is a integration constant. Okay, so now we can write f of z. Now this is also harmonic. Okay, so because this u is a harmonic, and if this two function is harmonic, then this f of z is a analytical. So we can write from given that is for the u, that is 2x plus y cube minus 3x square y plus i2 into this v, that is 2y minus 3x y square plus 3x into y plus c. Okay, so this is our final task, that is corresponding f of z is analytical, that is a corresponding f of z. Okay, so okay, let's stop here. Okay, thank you.